Let us begin. This is the spring exam review for Algebra 1. And this portion is also for Honors Algebra 1, so it's for both of you guys. Number 1, solving each inequality. You have to remember that our goal when we're trying to solve for a variable is to do the opposite of what's being done to it so that we can get the variable by itself. We want m by itself. At the moment, 5 is being added to it because it's m plus 5. So we do the opposite, and we subtract 5 from both sides. So that cancels out the 5's over here, and negative 2 minus 5 is negative 7. On number 2, x is being divided by 3. So we need to do the opposite of divide by 3 and multiply both sides by 3. That is a multiplication dot, at least it's supposed to be. So these 3's cancel out, and 12 times 3 is 36. Okay, on number 3, r is being multiplied by negative 3. So we need to do the opposite of multiplication and divide both sides by negative 3. That cancels these out, and 24 divided by negative 3 is negative 8. And whenever you divide or multiply by a negative number on both sides, like we did here, you have to flip the sign or the direction of the inequality so it changes from greater than or equal to less than or equal to. Number 4, we do have variables on both sides this time. I usually find it's best to go ahead and combine the two variables. And you could move the 4x over here or the 2x over here. That's truly just your preference. I chose to subtract the 2x from both sides, so that canceled this one out. It gave me 4x minus 2x equals 2x. So now we have 2x minus 7 is less than 9. So just like I wanted to get the variables together, I also wanted to get the constants, the things without variables together. So it was being subtracted by 7, so I'll add 7 to both sides. That cancels these out, and 9 plus 7 is 16. So our last step, since x is being multiplied by 2, we need to divide both sides by 2, canceling out those 2's, and we get 16 divided by 2 is 8. Number 5, we had variables on both sides here, 4t and 4t. So again, my preference or my style it's not required, but when there's variables on both sides, what I do first is combine the variables. So I subtracted 4t from both sides, but that actually canceled both of them out on both sides because they were both 4t. So all that's left was the 7 greater than 11. As you probably know, 7 is not greater than 11. That means there's no solution to this. There's no value of t that can make this true. Now it is possible sometimes to get a true statement. So let's just say I'd gotten 3 is less than 5. So the variables disappeared, but what I got was a true statement. If that happened, you would say all real solutions or infinite solutions or something like that. But since we got something false, we would say no solution. Okay, similar on number 6. Only difference is here we're also going to graph. So we want x to be by itself. We're subtracting 11 from it at the moment. So we got to do the opposite and add 11 to both sides. That cancels out the 11's. 3 plus 11 is 14. So we have x is greater than 14. If it's less than or greater than, you put an open circle. So I put an open circle on that number, 14. And since it says x is greater than 14, I have to shade to the right the numbers that are bigger than 14. 7, I need to first subtract 4 from both sides to get rid of that 4. So that cancels out the 4's. 7 minus 4 is 3. Now x is being multiplied by negative 3, so I have to divide both sides by negative 3. That cancels those two out. And 3 divided by negative 3 is negative 1. And just like we talked about on the first page, if you multiply or divide by a negative number on both sides, you have to reverse the sign, or the direction, of the inequality. So it switches from greater than or equal to less than or equal to. Anytime you have an or equal to, the line below it, then you put a solid dot, a closed dot. on that number. And since we had to switch it to x is less than -1, we have to shade everything that's smaller than -1 off to the left. Okay, number 8, which of the following is the graph of the solution set m is less than -1 and m is greater than or equal to +1. So one thing you could do if you wanted to is just kind of draw it up here for yourself and see which one matches. So at -1, we have an open circle because it just says less than, and I'd shade it this way because that's all the numbers that are smaller than -1. For m is greater than or equal to +1, we put a closed dot at +1 because it has an or equal to, and it says greater than, so we'd shade to the numbers that are bigger than +1. So as you can see, the only one that has two arrows going two different directions is D, and it matches what we have as far as the dots as well. So that's why the answer is D. Okay, to graph these inequalities, just like we do with equations, we start with our first point being the y-intercept. The y-intercept is the number that's by itself, has no variable with it. So in this case, the y-intercept is +2. So I start at the origin and go up to 2 on the y-axis. That's my starting point, the y-intercept. That's where the line hits the y-axis. Then the slope tells me where to go next. The top number always tells you what to do up or down, and the bottom number tells you how far to go to the right. So that's telling us to go down 1 and over 3. So starting at our y-intercept, we go down 1 and over 1, 2, 3. That's where we draw our other point. And just like a greater than or less than makes us use an open circle, a greater than or less than makes the line dotted instead of whole or solid. So I know this shading part often confused people, so I'm going to try to make it as plain as I can. If you think about this line, it really splits the graph into two spaces. There's a space kind of below the line and the space above the line. One of these spaces, this statement is true. One of these spaces, the statement is false. And all the points in one side will either be true or false. So I use 0, 0 just because it's easy to evaluate when you plug in 0, 0. So I plugged in 0 for x. I'm testing this point right here at the origin. Plug in 0 for x, plug in 0 for y. -1/3 times 0 is 0. 0 plus 2 is 2. So we have the statement that 0 is greater than 2. So if we plug this number, 0, 0, this ordered pair, into the equation, the result gives us a false answer. So this inequality does not work down here at all. So we will not graph on any of this part, because if that point gives us something false, everything on this side of the line will give us something false. So instead, we'll shade the area above the line. Another way you can think about it, this says y is greater than. When it says greater than, you're going to almost always be shading above the line. Okay, so same process with number 10. Just like with the equations, we start by graphing the y-intercept, which in this case is -3. So we start at the origin and go down 1, 2, 3. That's our first point. Then the slope tells us where to go next. Now this was just a 2, whole number 2. But we always want a fraction to help us know how far to go up and over. So I just rewrote it as 2 over 1, which is equivalent. So that's telling us to go up 2 and over 1. So I go back to my y-intercept. That's my starting point. And I went up 2 and over 1. And I did it a couple more times just to help me draw as straight of a line as I could. But you don't have to do any more than just 2 points to have a line. And again, since there's no or equals to, that's why we have a dotted line. So I'm going to choose to test 0, 0 again. When I plug in 0 for x and 0 for y, 2 times 0 is 0. 0 minus 3 is -3. 0 is greater than -3 is true. So that means this point, the origin, is a true thing that does work in this inequality. And if that point works in the inequality, then every point on this side of the line will also work in the inequality. So that's why we shaded it on that side. And again, it says y is greater than. So that's a hint that almost always, when it's greater than, you'll shade above the line. Okay, 10, we are switching to equations. So let's graph first, and then we'll talk about the solutions and the descriptions. So this was just a negative sign. Actually, let me just start here. Because like I said, we start with a y-intercept. So the y-intercept is 3. So we start at the origin and go up 1, 2, 3. That's my first point. Then I had a negative x. So that's all it said was negative x. But a negative implies it's a negative 1. And as I said, we want a fraction so we know how far to go up or down and over. So the negative becomes negative 1 over 1, meaning I start at my y-intercept and go down 1 and over 1. So that means this top equation is that line. Now this line also has a y-intercept at 3, but its slope was an understood 1, so 1 over 1, positive 1. So it went up 1 over 1, up 1 over 1. See, my line wasn't perfect. It happens. So this goes with that line. The solution is where the two lines meet. These two lines meet at the point 0, 3. They happen to meet at their y-intercept. And as far as these words, consistent means there's at least one solution. Now there is one solution because that's where they overlap. So that's why this one is consistent. And then for the ones that are consistent, they're either dependent or independent. Dependent means they're the exact same line. Independent means they are two different lines. Well, this is clearly two different lines. So that's why we would call this one consistent and independent. Now the only word I didn't talk about is right here, inconsistent. That means there is no solution. That's going to happen when you have two parallel lines that are separated from each other. They never touch, so they have no solution. Okay, 12 is going to take a little bit of work before you can graph it, because they're not in slope-intercept form, and that's harder to graph. So we want to get y by itself, just like it was on number 11, and just like it was on the previous two. So my first step is to subtract 4x over to the right side. So I get negative 2y equals negative 4x minus 6. Now y is being multiplied by negative 2, so we have to do the opposite and divide everything by negative 2. So when I divide this by negative 2, it just cancels out the negative 2, leaving y. Negative 4 divided by negative 2 is positive 2. Negative 6 divided by negative 2 is positive 3. So this is our first equation right here. The y-intercept is 3, 1, 2, 3. The slope is 2, which we can write it as 2 over 1. So we go up 2 over 1. So you draw a line through those 2 points, and we have that. So now let's rewrite the second equation and see what we get. I want to get y by itself. So I subtract 6x from both sides so that the negative 3y is by itself. That gives me negative 3y equals negative 6x minus 9. Y is being multiplied by negative 3, so we need to do the opposite and divide everything in this equation by negative 3. So we divide this by negative 3, cancels out. Divide this by negative 3. Negative 6 divided by negative 3 is positive 2. Divide this by negative 3. Negative 9 divided by negative 3 is positive 3. So if you notice, these two are identical to each other. So there's no need to make another graph because those two lines are identical. They're the same line. So they have infinite solutions because they're touching each other everywhere. It's literally just two lines on top of each other. So they're intersecting or crossing. They're the same everywhere. So there's an infinite number of solutions. And because they have at least one solution, they are consistent. And because they're the same line, they are dependent. Can't have one without the other because they're the same thing. Switching gears to systems of equations. That's when you have at least two equations. And just like with the graphs, we were trying to find out where do they overlap, where are they the same. We're doing the same thing with these equations. We're just trying to figure out, just instead of with a graph, with algebra, where do these two meet? What value of x and y would make these two the same? So you always want to get one variable by itself, which they gave it to us already here, y equals 3x. So since we know y is equal to 3x, we can substitute 3x in for this y right here. So we'll just rewrite this equation, x plus, but we'll replace the y with 3x equal to 4. So I'm substituting something else I know y is equal to, 3x, in for the y in the other equation. 1x plus 3x equals 4x. And then x is being multiplied by 4, so to get rid of that, we need to divide both sides by 4. These 4's cancel, and 4 divided by 4 is 1. So we've got half the solution. We know the x value, but we also need to know the y value. So here, you can plug the 1 in for x in this equation or this equation. It does not matter which one, you'll get the right answer either way. I plugged 1 in for the top equation, so I got y equals 3 times 1, meaning y equals 3. So the best way to write the final answer is as an ordered pair, 1 for the x, 3 for the y. If you do write an ordered pair, make sure you put parentheses around it. It's not an ordered pair without parentheses. Okay, 14 is a little bit tougher because they don't have a variable already written by itself. This one already had y by itself. This one doesn't have x or y by itself. The easiest one to get by itself is going to be this y. So I subtracted 5x from both sides and got negative y equals negative 5x plus 10. But I can't have it be a negative y, I need it to be a positive y. So I multiplied everything on both sides by negative 1. And you can multiply by negative 1 or divide by negative 1. The result is the same either way. So negative 1 times negative y is positive y. Negative 1 times negative 5x is positive 5x. Negative 1 times negative 10 is negative 1 times positive 10 is negative 10. So that took more work on the front end to get the y by itself. But now we can take y equals 5x minus 10 and plug it in for the y in the other equation. So I'm rewriting this second equation exactly as it is, 7x minus 2, but instead of putting y, I put in 5x minus 10, and I set it equal to 11. Next, we'll distribute the negative 2. Negative 2 times 5x is negative 10x. Negative 2 times negative 10 is positive 20. So then I did two steps in one right here. 7x minus 10x is negative 3x. Then I subtracted 20 from both sides and got 11 minus 20 is negative 9. So then I divided both sides by negative 3. Negative 9 divided by negative 3 is positive 3. So that gave us our x value. Then you can plug that into either equation, doesn't matter which one of these. I plugged in the top one, so I got 5 times 3 is 15, minus y equals 10. So y must be 5, because 15 minus 5 is equal to 10. So I get the ordered pair with 3 for x, 5 for y. I'll leave that up there just a second to make sure you can check on it. Okay, so we're still solving a system of equations, but this time we're doing it with elimination. When we're doing elimination, we want things in standard form, and then add or subtract the two equations to make one variable disappear. So like on 15, we have a positive 2x and a negative 2x. So when signs are different, you can add the two equations together to make them disappear. Because 2x plus negative 2x is 0, it's gone. Negative 5y plus 3y is negative 2y. Negative 16 plus 12 is negative 4. So we have negative 2y equals negative 4. That's the result of us adding these two equations together. Then we've got y times negative 2. So to get rid of that, we divide both sides by negative 2. Cancels those out. Negative 4 divided by negative 2 is positive 2. Now I'm not going to spend as much time talking about how to plug it back in because that was the same in substitution. So I'll just say plug 2 back into either one of these equations. For y, I did the top one. You can see the work here. You'll get the x value, which in this case was negative 3. Okay, 16 is an uncommon situation, but we could actually add or subtract this one in order to eliminate a variable. Because if you wanted to eliminate the x's, they have the same sign, positive 1 for both. You could subtract. But if you want to eliminate the y's, you could add because they have different signs. And truly, either one's fine. You can get the right answer either way. I chose to eliminate the y's because in general I think it's quicker to just add the two equations together. So 1x plus 1x is 2x. 4y plus negative 4y is 0. Negative 8 plus negative 8 is negative 16. So I didn't show this step, but I would divide both sides by 2 to get rid of that 2. And I get x equals negative 8. And again, I'll just tell you, you then plug negative 8 back in for either of the x's and solve for y. And you'll get negative 8, 0. Feel free to pause if you want to see the work on how I got the 0. Okay, 17 is the toughest of the group because none of the coefficients match. That's a 2 and a 1. I mean, it's a negative 1, but 2 and a 1. That's a 5 and a 3. So there's more than one way you can make these match, but in short, you have to multiply one or both equations by a number in order to make it so that at least one of the variables does match. So I chose to multiply this bottom equation by 2. When I do that, I have to multiply every piece in the equation by 2. So 2 times negative x is negative 2x. 2 times 3y is 6y. 2 times negative 7 is negative 14. So you can kind of ignore this middle equation now because I've transformed it into this one. So since they're different signs, 2x and negative 2x, I'll add this top equation to this bottom equation. 2x plus negative 2x cancels out, makes it 0. 5y plus 6y is 11y. 3 plus negative 14 is negative 11. Then to get rid of the 11 with the y, you divide both sides by 11, cancels it out. Negative 11 divided by 11 is negative 1. You can then plug negative 1 back in for one of the y's and solve for x and get 4. Okay, on 18, we do have some matching numbers, 2 and 2. Since they have the same sign, we'll need to subtract the two equations from each other. So we've got to make sure the x's get canceled out. So 2x minus 2x is 0. Those go away. Make sure you subtract all the way through. 5y minus y is 4y. 9 minus 13 is negative 4. Then we need to divide both sides by 4 to cancel it out. Negative 4 divided by 4 is y equals negative 1. You can then plug negative 1 in for either one of these y's and solve for the x in its equation, and you'll get 7 as the x value, negative 1 as the y value. Okay, 19 is one of the trickier ones, so I'll try to go through as clearly as I can. This is similar to what we did back on number 11 and 12. The only difference is we also have to think about the shading we have to do with these. So I just started with the top equation. All I did right here is rewrite it just as it is. We want to get y by itself, so it's in slope-intercept form, to graph it. So I added x to both sides. That gave me x plus 8. I put a 1 in front of it. I'll explain in a second. But you just get x plus 8. Then you have 4y is less than or equal to x plus 8. Then we divide both sides by 4. So that cancels out these. And then here's why I wrote the 1 in front of the x. Because you know x is 1x. That should make sense. But people are not sure how to write this or simplify this often, so I just said, okay, that's 1x divided by 4. So I can just say 1 divided by 4, or 1/4, x. Then 8 divided by 4 is 2. So now we're in slope-intercept form. Just like before, we always start the graph by using the y-intercept. So that's 2. So I start by drawing this line. I start at the origin and go up 1, 2. So this first point is the first point for this top equation. The slope is 1/4. That tells me starting at the y-intercept, I go up 1 and over 4 to this point. Then I can draw a line through those 2 points. So then I can test to see where I should shade. Now this is a little trickier because we're going to have to test 2 different lines. So try to watch what I'm doing. I chose to pick 0, 0 like we have before. I know that's on this line, but we haven't gotten to that line yet. So I'm just saying this line that we just drew separates the graph into 2 pieces, the upper piece and the lower piece. So I picked 0, 0 because it's on this line's lower half. When I plugged in 0 for x and 0 for y, I got 0 is less than or equal to 2. That's true. So at first I just drew some arrows to show me, okay, I will need to shade below this first line that I drew. Now this one, thankfully, is a little less work to graph. It's already in y-intercept form, but you notice there is no number all by itself over here. There's nothing written. So that means it's actually a y-intercept of 0. It starts at the origin. There's like an understood plus 0 there, or minus 0. So you graph at the origin to start with. Then the slope is 2, which can be written as 2 over 1. So we go up 2 over 1 and draw the line. This isn't common, but it happens sometimes. I cannot use 0, 0 as a test point because we can't use test points that are on that line. It was fine to use 0, 0 for this line up here because this line never touched that. But this line does touch 0, 0. But you can pick any point you want that's not on the actual line itself. So I chose to pick this point right here, 1, 0. So I plugged in 1 for the x using this equation right here. Plugged in 1 for x, 0 for y. That gives you 0 is greater than 2. Now when I first did this, I made a clear mistake and said, oh, that's true, then shaded the wrong way. So in reality, 0 is not greater than 2. I know, it shocked me too. So since it was over on the right side of the line that I got a false statement, that means I would need to shade to the left of the line. So where these two are both true is in this segment right here. So this is just a mistake on my part. This should not be shaded at all. It's this lower left that should be shaded. Okay, how about some quicker ones? When we're multiplying, we add the exponents together. So 3 plus 2 is 5. 6 plus 4 is 10. When we have exponents outside the parentheses, we'll need to start by applying them to what's inside the parentheses first. Then we can combine using the rule we used in number 20. So I square everything. 2 squared is 4. And when I have an exponent raised to an exponent, I multiply them together. 3 times 2 is 6. The understood 1 above the r times 2 is 2. Negative 2 cubed is negative 8. 4 times 3 is 12. 3 times 3 is 9. So take a second and get through that if you need to. Because again, the difference is when you're multiplying two things together, you add up their exponents. When you have an exponent outside the parentheses, then you're really doing an exponent raised to an exponent. That's when you multiply them together. So we have 4 times negative 8 is negative 32. 6 plus 12 is 18. 2 plus 9 is 11. So we've talked about what to do when you're multiplying. You have to add the exponents. When you have an exponent raised to an exponent, you multiply them. When you divide, you subtract the exponents. So my first step here would be to say, okay, let's look at the p's. 4 minus 2 is 2. 2 minus 6 is negative 4 for the n's. Now this is not incorrect mathematically what I've done, but we've got to look at the directions. It says answers have to be in positive exponents only. So it's not that this step is wrong, it's just that we're not done. We need to change this, rearrange it, so that the n has a positive exponent. And the way you can do that is by moving the n to the denominator, because anytime you change something from the numerator to the denominator, it changes the sign of the exponent. So moving it to the bottom makes it p squared over into the fourth. Okay, last one, 23. We've got to apply several rules here. First, we have an exponent raised to an exponent, so we'll multiply 2 times 2 and get 4. Negative 1 times 2 and get negative 2. 2 times 3 and get 6. 2 times 3 and get 6. I want to show you two routes you can go with this. The route I'm showing right here is identical to what we did in number 22. I subtracted 4 minus 6, negative 2 minus 6, and then to make these positive exponents, I moved it to the bottom. If that works for you, great. Keep it up, go for it. Another way you can approach it is say, okay, let's look at the d's. Where do the d's have a bigger exponent, in the top or the bottom? Clearly it's the bottom. So since the bigger one's on the bottom, I know that's where this is going to end up. So I start from the bottom and then subtract 6 minus 4 and get 2. Same with the f's. I look at which one has a bigger exponent. It's got to be the one on the bottom here. That's a positive 6 versus a negative 2. So I'll start here and say 6 minus negative 2, which is the same as plus 2, which gives us 8. Okay, I think that's enough for one video. I will complete more soon.